Alright everyone, so this is the other example that we did in class. We have a tractor that's hitched to a sled, and then it's loaded down with firewood and pulled a distance of 35 meters across a frozen pond. We know the total weight of the sled is about 13,450 newtons, and the tractor exerts a constant force of 4,500 newtons at an angle of 46.2 degrees above the horizontal, while the ground exerts a constant friction force of 2,500 newtons. We want to find the work done by each force, and then we want to find the net work. And then we're going to do it the opposite way. We're going to find the resultant force and the work done by that resultant force. So first we're just going to draw a free body diagram of the sled. We have the force of gravity pushing down on it. In the opposite direction, we're going to have the normal force pushing up on it. And then the forward force of the tractor pulling it, and the force of friction working against it, pulling in the opposite direction. And so for the first part, we want to find the work done by each one of the forces, and then we're just going to find the net work by adding each one of those works. And so remember that because gravity and the normal force are perpendicular to the direction which the tractor travels, the work done by both of those forces is zero. And so we find the work done by the tractor and the work done by friction. And because work is a scalar, we can just add the two to determine the net work on the sled, or the net work that's done to the sled as it moves 35 meters. We find the net work 21,512.5 joules. So now for part B, we're going to find the net force and then use the net force to determine the net work. And remember again that the normal force and the force of gravity would add to zero because they're in opposite directions, but they're equal. And if we talk about the forces in the x direction, we need the component of the x force from the tractor as it's being pulled minus the force of friction. And so we can determine the net force on the sled. And from the net force, we should be able to multiply times the distance that the sled travels. And we find that the net work in this case, is equal to the net work we found in part A.